All right, welcome to section 9.4. We are looking at direct variation and varies inversely. With a direct variation, basically what that says is x increases, y increases. If x decreases, y decreases. With an inverse variation, as y gets bigger, x will get smaller. Or as x gets bigger, y will get smaller. Okay, that's the difference between direct variation and varies inversely. All right, but the other thing we will need to be able to do is we are solving for this k, which we call a constant. In order to be able to do these equations, we have to determine what our k is. So to be able to find k, I would be able to divide by x, both sides by x. So I know k is equal to y over x. And same with inversely. How do I get k by itself? Well, there's x, it's divided by x, so I'm going to multiply both sides by x. So therefore, k is equal to xy. And we're going to need to be able to work with those. You only really need to know two of these equations because you can come up with k all by itself by solving, by using just some simple algebra, but you can have both of those sets of equations for each one. All right, so you might get something that says if y varies directly as x, find the constant of variation k and the direct variation equation for the situation. So the first thing I need to do is write down my y equals k times x. So my direct variation equation, y equals kx, okay? So the first thing I will have to do is find k. In order to do that, I'm going to plug in 3 for y, so I'm going to have, well, and since I've already solved for k, I'm going to use k equals y over x. So here I go, I'm going to go y, k equals y over x. I'm going to actually plug my values in, which is 3 over 24. And I'm going to simplify that down to 1/8. Okay, so that's my k. I found my k. The other thing I'm going to have to do is now find my direct variation equation. So that just means literally taking the y equals kx and plugging in 1/8 for k and leaving it just like that. So y is equal to 1/8 x. Okay, so you'll have two answers when you do these problems. You'll have to find your k, and then you'll have to find the actual equation, write the actual equation. All right, if y varies inversely with as x, find the constant of variation k with the inverse variation equation for the situation. So remember that equation is y equals k over x. Okay, but I need to know my k. So my equation for k is equal to x times y. I'm going to plug in my x and my y. So the x is 10 times 6, which equals 60. Okay, so k is equal to 60. Then I'm going to actually plug the k in, so y is equal to 60 divided by x, and that's my inverse variation equation. So I have one answer, k is equal to 60, my constant is 60, and my equation is y equals 60 over x. What about when we go to something that looks more like this? Okay, so it says pairs of markings a set distance apart are made on highways so that police can detect drivers exceeding the speed limit. Over a fixed distance, the speed r varies inversely with time. In one particular pair of markings, r is 51 miles per hour when t is 77 seconds. Fine. Oh, this should say, actually, sorry guys, that should say 7 and this should say 8. Find the speed of a car that travels the given distance in 8 seconds, okay? So what this tells me is r varies inversely with t. So that means R is equal to K over T. All right? So now I need to find my constant, K, when I know R is 51 and T is 7. So I'll multiply both sides by 7, and that gives me 357 is equal to K. Now I know my equation is now R is equal to 357 over T. So, okay, so that's my new equation. Find the speed of the car that travels the given distance in 8 seconds. So now I need to replace T with 8. So R is equal to 357 over 8. So R is equal to 44.6 miles per hour. All right. So with that in mind, you'll have to look to see where they tell you to round. I would guess 1 decimal. They may even tell you 2. Just make sure you pay attention to what they say. You also might get something that looks like this. For the statement, find the constant variation in the variation equation. Y varies directly as the cube of x. Okay, so what that says is y is equal to k times x cubed. All right, so that's a really big thing. X is cubed, so therefore we're going to plug in 25 is equal to k times 5 cubed. Okay, I'm going to divide by 125 because 5 cubed is 125. And I'm going to come up with 1/5 is equal to k. So my equation I will be giving is y is equal to 1/5 x cubed. Okay, and so we can have a little bit of variations, and you just have to pay attention to the verbiage. We can change up the equation. You just know that it sets up this, but we can cube this number. We could square that number. You just have to pay attention to how they state what they're looking for. Ask me in class if you have any questions or email me.